Hello everyone, welcome to day 11 of our AWS Masterclass. And in this particular session, we will be winding up our Lambda so that in the future we will be discussing some other different services and projects related to it. And with Lambda, we have done a lot of simple projects, right? We have started with the data set opening and then the image resizing code. Then we also done mail notification, then SMS notification by integrating SES and SNS. And here what we are going to do is in Lambda, if you have seen when you try to create a function, it would have asked for you could create with containers. So that's what we will be doing. So many of you guys don't know about what a container and all. So I'll be discussing about what are some microservices in this session. And after that, we'll be using ECR to register it and then use it in Lambda. And once we're done with that, finally, we will be doing another one simple small project. It's actually an idea-based project which you can do. I'll be showing some glimpse and a small application will be done from my side. But the important task in that is what you can do is you can configure it for some other events or some other thing if you want to perform based on the time schedules and all, you can do it. So that we'll be discussing after this. So first let us see about microservices, then Elastic Container Registry. I'm doing it with Lambda with a simple project. And after that we'll go into EventBridge. So starting with that. So what is called as containers? Okay. So containers in general, what is a container? It's for storing things, right? So here in programming, okay, containers are a lightweight and isolated unit of software packaging, okay, that include everything needed to run an application such as code, runtime, system tools, libraries, etc. along with the code. And containers provide a consistent and predictable environment for software to run regardless of the underlying infrastructure. So I'll tell you a use case example. Previously, before this containers, when developers were developing some kind of applications, like they will be client, okay. So the client will tell he needs this kind of application, so the developer will developing that application. So all the requirements will be done. So the developer, what he'll do is he will make everything in his laptop. It will working very fine. So what he'll do is he will pass it to the testing team. And in software, we have a group of testing teams. So we have manual testers and automation testers. They will test whether it is working in the way it is supposed to be. Okay, whether it's working correctly or not, they will be testing it. And if it is like, what happens is, in those days, sometimes what will happen is the developer, he will be using one kind of laptop where he will be having some kind of OS, some infrastructure will be there, some OS will be there, some configurations will be there. Some libraries will be there, everything will be different. When you go for the tester or the client system or computer, where it is going to be different. So whatever thing running in his system won't run properly in some other systems, okay, some other environment. So this is actually a big issue, and to overcome this, they will be suggesting these are the properties you want to follow. So if you have this application will work on these alone, okay. So it will be work better in these structures, okay. It will be providing. And that's when the containers came into play. So this container is something where you will package everything, okay. It will contain what is the OS, what is the code, what is the runtime, okay, along with the libraries. If you use pandas, you will be having pandas there, it will be installed, okay, so that nothing goes missing, okay, there will be no error. So it can provide a predictable environment for software to run regarding of the underlying infrastructure. So whatever system you are running this, if you have this container, that application will be running, okay, it will download everything which is required and it will be running. And that's what the work of a container is. So you can ask what is the difference between a container and a virtual machine is, okay. So virtual machine, we are having an infrastructure, we are providing it through like cloud, okay, and you have an operating system, okay. So the thing is, in virtual machine, you will be separating the infrastructure with something called as hypervisor, where you will be splitting it into partitions. So for different partitions, you can create guest OS and they will be using their applications, right, along with the bins and libraries. But the thing is, sometimes this user, he may have some empty spaces which is not used, okay, and this user may require some additional spaces, but they cannot use, okay, they cannot mix and use here. But when you go for containers, you also have another option where this is a shared storage, okay. So this operating system will be there and a container engine will be there and users will be having their own containers. So the space is also efficient here when you go for containers. So these are some of the difference between how they work. So operating system is dedicated for each in virtual machine. It is shared in here containers regarding their efficiency, portability, okay, and disk space. So these are containers, and one of the common container tool if you have here, it is Docker. So it's like you can use it from command line interface. You can learn more about it, okay. And then moving into the next one, which is called as microservices. So this microservices and containers are interrelated. So how do I tell you is, when you talk about microservices, let us understand it first, and then we'll come back to containers and how containers are helping microservices. Microservices is a software architecture, okay. It's a type of development where an application is built as a collection of small independent services. I think now it makes sense. Just see this image. Instead of building one entire thing, they are building many different parts and they are interconnecting it, okay. The same way, once if you want to build a big software application, instead of combining everything in a single one, you are splitting it into parts so that each individual thing will do its own work and it will collaborate also, so that the output will be achieved. So since a microservice architecture consists of units that run independently, each service can be deployed, updated, okay, developed and scaled without affecting other services. So for example, you are having multiple services. If you have error in any one of this service, you can just check that and modify that. If you want to update, you can update that and make it work so that others won't get updated or affected. So the opposite of the microservice, which is the thing which is called as monolithic, where the entire thing is a single one indivisible unit. Here it is split into parts, okay. And this microservices, how it is achieved is, microservices can be achieved through containers by packing, okay, or packaging each microservice and its dependencies into separate containers. So each container represents a self-contained unit that provides the necessary isolation and portability to deploy and manage microservices effectively. So if I tell you, for example, if you are having a web application like Amazon, okay, you want to buy products, you can build it at a single application or you can build it into parts, okay. Each thing will be different, like the payment portal will be a different microservice, the selection portal will be a different microservice, the registration portal will be a different microservice, okay. So everything will be in a container and they will be interconnected so they can work, okay. So it is a lot advantage compared with monolithic. So you can have separate different things, okay, isolate it and create containers. No issues will be coming here. And one thing, so we are having containers, right? For each service, you can separate it into small parts and have containers for each and then combine it. So now we know containers. Yeah, there is something like a software like Docker, which can be used for creating containers. You can mention, like, there is a separate format for it. You can mention you can take a base image and take that OS, install some libraries and make it work for your code. We'll be doing that later. And now if you go for microservices, how are you going to connect all these guys? Okay, so the connection part is done with something which is called as container orchestration. So as the name itself defining, container orchestration is something like you are going to combine all the microservices. So the container orchestration refers to the management and coordination of containerized applications across a cluster of machines or a distributed infrastructure. So the container orchestration automates the deployment, management, scaling and network of containers. Okay, so to connect all these things, you will be using something known as container orchestration. So you have a tool for it. It is called as Kubernetes. Okay, and in AWS you have Amazon Elastic Container Service. So it is a managed service that allows you to run Docker based application packaged as containers across a cluster of EC2 instances. For Kubernetes, it's the same Kubernetes, this tool for orchestration, but for AWS environment, they have managed to create something known as Amazon EKS, the same Kubernetes, but for AWS. So it's for container orchestration and that task. And I hope you can get a recap about what is containers, what is microservices, and what is container orchestration. We have Docker for containers and container orchestration. We have Kubernetes and we have some alternatives here in AWS. You also have another thing, that's what we are going to use. So these are some complex things. If you are developing a big app, then you need all these things. For the base version, initially I'll be suggesting you to go and practice with this Amazon Elastic Container Registry. So here you can store a container, you can create and store a container, which we will be having some code for AWS Lambda, which we have seen in previous module, right? So with that, we will be writing code, we'll be having libraries stored here, okay, and check whether it is working or not using Amazon Elastic Container Registry. Okay, you can write code, you can compress it and store it in this container. You have a lot of storage here. The thing with Lambda is in layers you have certain limitation. Okay, after 267 MB, if it's beyond that size, you cannot store it there. Okay, if you are having some complex code, it won't run in that place. And instead of that, you can go for zip file. That also has some limitations. If you want to have some big things, you can go and use this Elastic Container Registry. We'll be using this in this module. So starting with that, Amazon Container Registry is a managed container image registry service. We can use the familiar Docker command line interface or their preferred client to push, pull and manage images. So what we are going to do is, let me just go into our AWS. First, before going into that, we want to go into Lambda. Okay, so if you go into Lambda, if you want to create a function, it will ask whether you want to start from scratch. You can go and use a blueprint and you can get some samples here, okay, from Python or whatever it is, or you can go and use this container image. So what is this container image is? You can store it in Amazon ECR and provide that link alone here, that will be taken. Okay, ECR is a Elastic Container Registry. So what I can do is I'll search for ECR, Elastic Container Registry, and this is a repository. You can store containers. So now what we are going to do is we need a command line interface. You can do it from EC2, but I thought I can give you a glimpse of another service which is free of cost from AWS, where you can get a command line interface. Okay, we'll be using that. And what we are going to do is you can search for this AWS Lambda container. It will take you into the documentation of AWS working with Lambda container images. And if you go inside of it, you can see, you can scroll below and find which version you want. I need for Python. Okay, so this is the thing which I'm going to follow. Okay, so what's the prerequisite, what you need for creating an image? So these are the steps we'll be following. For this we need a command line interface, so I'm going to search for a new service, okay, which is free of cost. Let us search for something known as Cloud9. So this is a command line interface from AWS. You can see it is an IDE, a command line interface for writing, running and debugging code. You can write any code you want. You can create an environment. If you are new, you can give some name. Okay, and you can use which type it is want. It required a server, right? Let it use a EC2 instance. It will automatically create and let it use this. And you can go and create it. And it will take some time, several minutes. Once if it is done, you can go and use it. Now it has been done, so you can open it. It will take you into the IDE where it has its directory. You can go and use it. This is the home and this is the command line interface which is using EC2. This will be a little bit better. You can use this too instead of EC2 if you want. Okay, so first let us create a new directory, example or whatever directory you want to make it. So make directory workspace. Okay, and ls workspace is there. Change the directory into workspace and we are inside of it. So now what I'm going to do is, let me just shift here, and the thing is we want to have a file in the name of lambda function _py. If you wonder, it is the same file you are having here in the functions. If you go and create it something from the scratch, okay, it will be providing it that name only. I'll just show you. If you have seen it earlier in the code, in the left side you can find the name of it. You can see it's lambda _function.py and the name should be lambda _handler. So if you want to verify it, you can see in the handler, it will be having like lambda underscore function dot lambda underscore handler. Inside of this one. So if you are renaming this, you want to alter here also in the runtime settings. Otherwise, you will be getting some error. It won't be sorted down. So please be careful with that. So you want to do the same thing here also. So I want to create a file in the name of lambda underscore function dot py. So let me touch lambda underscore function dot py, and now we have this. Let me just move into like in the editor. I'll go and use this. Okay, so now we are inside of it and we can use these things. So this is a content, sample content. Okay, yeah, so first let us have it. We are missing that I. Let me add it, and we'll have some other things also. Okay, I'll import sys, and yeah, I'm going to have some other things like we'll create some error and then we'll sort it down, so that if you are practicing, you can also learn how to handle this error. I'm going to import pandas and I'm going to import CV2 here also. Okay, and yeah, let me just save it by pressing escape and colon wq. Yeah, so we have this lambda underscore function dot py, and yeah, now we are working with a container, so we need Docker. So Docker is having a Docker file. Okay, we will be having a Docker file. We'll be creating that, and before that you need to create a file in the name of requirement.txt. Okay, so this requirement.txt is a text file. It should contain what all the libraries you require, because in this Docker file, it will first install all the requirements.txt using pip install, and then it will run your Lambda function. It will make sense now, I think so. In Docker file, you can see it will first copy the contents, requirement.txt and lambda underscore function. The contents will be copied, and the requirement.txt file, whatever thing present inside will be ran through this pip install, so that whatever library you have mentioned will be installed first, and then this function will be started, so that you won't be missing that library and it will run properly. So this is how a Docker file will be. And here, usually here we are taking that image from AWS itself. If you are creating from the base a Docker file, you will be taking an image which has the OS, whether it's Linux or Windows or Ubuntu, whatever it is, and you will be writing other things like version and then how it should run, etc. So that's like how we defined it. Before creating a Docker file, I need to create a file in the name requirements.txt. I'll go with touch and then virtual editor. And if you remember in the code, I have imported pandas and OpenCV. First, let me just go with pandas. Okay, so I'm just going to have pandas. I'm not storing OpenCV. Let us get that error and then sorted it down later. Okay, so I'll just go with pandas alone here, and then also I need to have a Docker file. So all these things are stored here. Okay, and we need to create it in the name Docker file. So this is a format to create a Docker file. Yeah, so you can see the symbol of it, the Docker file, so you can go and edit it, and we are inside, right? So let me just copy this content and let me paste it. Okay, so it will install the requirement.txt and it will run this file. It will copy these contents and do it. That's what this will do, and I'll save and quit, write and quit. And if you check ls, we will be having all these three files which are important. And if you are done that, what you can do is you can scroll below and you can go with deploying the image. For that, you need to have a ECR repository. Let me go into ECR and the repositories I'm having right now. Yeah, please wait. So we don't have any repositories, right? So you can create here, or you can use the command line by following this. You can copy this. After this name, you want to pass a repository name. Okay, that is enough. We'll paste it, and yeah, the name is going to be, we'll give Pantech repo. Yeah, it has been created. So if you want, you can go and check here. If you refresh it, you can see it is created in this name. But how are you going to connect it? You have created a repository. There are a few steps for you to connect and upload all these things you are having here, these three inside of this workspace. So what you have to do is, You have to go inside of it, and you can call, this is Cloud9. Yeah, in the repositories, if you select, okay, or if you go inside of it, you can see something known as view push commands. Pushing is like updating everything here. Okay, here inside of it there is nothing, right? So let me view the push commands, and you want to follow through all these 4 steps. First you want to go through this. I'll copy it and paste it here. Login has succeeded. If you get this successful, you can go and use the next steps, which is building the repository. So it will go through all the steps from the Docker file. You can see it is pulling the image, which is the base version of Python 3.11. Whatever the OS it is having, it will be taken, and then requirements file and Lambda function will be copied, and then pip install requirements file will be done. You can see pandas will get installed. Okay, and then it will run the Lambda underscore function. So it will save it, and then it will upload it in the next line we are providing. See here, so it is installing pandas, right? So that's how every time you do it, it will be created there. It's a containerized environment in a container. So it's a segregated one where it will have all the required things there, so that nothing will be left out. Yeah, it has been done. Now you can go and follow the next step, which is the 3rd step. So you can tag it, and then you can push it finally. Yeah, and then finally the push command, I'll copy it, and you can see there is nothing here. I'll just push it from here. So it is pushing, which means it is uploading here in the container registry ECR. It is doing it. And once again, I want to remember you that we are missing OpenCV. Let us get that error, and then I'll tell you how you are going to update it. First time you are doing, you will be doing, but if you have some error, how are you going to update things here? I'll just show you after completing this. Yeah, it has been done. So if I go here and refresh it, I am getting the latest. Okay, so this is the thing which I am having. So it is now updated in this repository. Okay, this is a container, and I can go into the Lambda. Let us create a function. Here I'll use container image. So container function, you need to enter ECR image URI. So you can get it from here. You can copy it. Yeah, here it is, copy URI. Just paste it here, or you can browse that too, and then you can go and create the function. Okay, still it's a base function. You can have multiple things, like you can get the same SES alert. You can do it using this. You just want to write the code inside of it and the requirements you want to give. If you are doing that image processing, resizing task, you can do that too. You will be having your OpenCV etc. requirements here, and then it will be running properly. So now it's creating the function. You can see that code. You won't be getting any preview here because you are using an image. You can check it there, and yeah, let us go with the test event. I'll create a test, and let us try. We should get error that OpenCV is missing. Okay, I'll save it, and in the details we should get that it's an error. Unable to import a module in the name CV2. Okay, because in the code we are having CV2, but in the requirements we don't have it, right? So we have only pandas. So I'll go and call requirements.txt. So we have pandas, right? So I'll alter it. Along with that, I need OpenCV. You remember the name, OpenCV Python headless, right? So I'll press escape, write and quit. Yeah, so now what we need to do is, if you want to update this, you can go into the push commands and search for this line, build. The second line you don't want to configure once again. So since I have changed this in the local, I want to push it to my repository. Okay, I'll just go with Control V. Yeah. So now it will take from the previous one. Pandas is already there. It will go and install OpenCV Python headless. You can see it is installing here. And once it is done, it will be builded. And then you can do the remaining steps and push it once again so that it will run properly without any error. Apart from that, you can have any code inside. So if you are trying to build a complex thing, it requires a lot of space, and in Lambda you don't have that much space in the layers. You will be getting error. If you have multiple libraries, that space is not there, you don't have this library etc. you can use this at that time. Let us go and copy this command and build that, finally push it. So as you can see, right now we are having only this latest image. You can check the time also if you want to confirm. But if I go and push this here, these are already existing, only the new things will get updated and we will be getting a new layer. Whatever thing is the new, it will have the latest name. So once you have that, let me teach you how you can connect it from Lambda. Yeah, it has been done, and you can go and refresh this. You can find this is a previous one, this is the latest one. So you can use the latest, you can copy the URI, but here if you want to update it, if you want to change new thing, you can go and click this deploy new image, and you can browse for this image. You can select the repository. Okay, this is the repository, right? You can select the latest version, or you can paste the URI directly, same things. This is 28 seconds ago. I'll just select this image and save it. And now the OpenCV error should be sorted down because we have installed it. Now if it is running fine, then you can have any code which is running like this. This is how we will be creating a container. So if you are familiar with the container, you can explore more about microservices and creating multiple containers and orchestrating it through Kubernetes, etc. Yeah, it has been done. So let me test it. So this should tell that, it shouldn't tell that OpenCV error. If it is giving the base output, then it is successful. Yeah, it is executed successfully, which means whatever thing we planned got successful. So that's how we will be using container to face the Lambda also. We have seen all of these things. So before winding this class, let me just tell you how to clear all these things. You can close all files. If you have started, you can remove all these things. If you don't want this container, you can go and delete it. Whatever things inside of it will also get deleted. So please be careful with that. Okay, this is Cloud9 environment. And here if you want, you can delete these two also. Here also the container images, everything stored inside of it will get deleted. And once again the functions, after using, if you don't want it, you can delete it. Here also you can have the container. Even though you have container, you can have trigger and you can do the same task. Only for the supportive purpose of not missing any library and make it predictable in all the environment, we are using containers. Yeah, this will be deleted in some time. So you can use some of these documentations if you want. You can explore. If you are trying new things, you can follow the documentation from AWS. Continuing with that, we are going to discuss about something known as EventBridge. Okay, so this is the last service which I have discussed, so which we will be integrating finally with Lambda. Not only that, Lambda has a lot of application with a lot of more services. If you are interested, you could check that too. And if permits, we could, if time permits, in the later on in this course, we can also try to integrate it with some more services and do some simple useful projects. So starting with this EventBridge, it's actually a service from AWS. Okay, and talking about EventBridge, AWS EventBridge is a serverless event bus service that simplifies the integration and routing of events between AWS servers, applications, and external resources. So it provides a unified way to collect and process events from various sources, making it easier to build event-driven architectures. And EventBridge also allows you to set up event rules and targets such as Lambda functions or SNS topics to respond to specific events, and automating workflows can be done with that. For example, what we are particularly going to do here is, I'll tell you what this EventBridge is. It's like an event if you want to schedule, or if something happens, like a trigger, you can set it even as a trigger, or time based you can do it. For example, in the first case scenario, if I set it as an event, if something happens, just do this. You can schedule it. It's like a serverless event bus. Okay, it's like a trigger which you can set. That is one application. Not only that, okay, so you can do, like, if something happens in this particular bucket, send me a mail. You can integrate with SNS or ACS and achieve that. Not only that, for example, if I want to do timely being, like for example, every day I want to do some automation tasks which I can done with the help of this. Okay, so for example, I can schedule this EventBridge to every day. So if I set that, what will happen is, what is the code if I have, that will be executed every day. Okay, it's like a event, you can schedule it. Okay, so you can particularly schedule, for example, coming week end, I just want to have on Sunday, I want to just execute this particular task. Then what will happen is, it will execute on particular that day and then wind up. That is available. Or if you want, you can want to do it every Saturday or every Sunday, you can do it. Every day you can do it, every minute. Okay, you have the option of minute, hours and days. You can do it in such cases. You can schedule it, and in such places it will be repeating. So that's the idea behind it. You can use it for scheduling. Not only that, you can integrate with Lambda functions. And we know, for example, if I want to execute some task in Lambda, if I have the code and if I want to execute it in like every day, okay, what I can do is I can set this EventBridge. So every day that Lambda function will be ran once. And if you want, you can get alerts. If you integrate SNS or SES, you will be getting alerts, right? Like we discussed in the previous session. So it's one of the interesting thing which you can do it for automation. It's also a serverless. And before starting with that, you could also check for safety purpose AWS free tier, and you could check for the EventBridge. What's the free tier option? Scroll below and type event. Okay, EventBridge. It's not recognizing, or AWS EventBridge. Okay, if it is not available, then it's not a free tier service. Which means you need to be careful. Anyway, it's low cost, but we don't. It seems like we don't have a free tier in this EventBridge. Okay, so yeah, this is about that EventBridge. You can have custom apps or SAS or microservices. A event which will happen. If it happens, you can trigger and do some other task. Okay, you can bind with the code from AWS Lambda or SNS or EVP destinations and so on. Okay, and let me check for the prices. Okay, don't have. Okay, it seems like it's free. All state changes events published by AWS services are free. Fine, we'll check EventBridge. We'll check it in the console. Anyway, I can go into the EventBridge serverless service for building event-driven applications. Okay, there is no upfront or minimum cost. You pay for what you use. If you want, you can get the cost calculator. I'll just show you guys sample. So it seems like you have to pay for it. So you need to be careful with that. If you don't want, just don't use it. Just listen to the sessions and then wind it up. Okay, so we'll be using that anyway later on. We also need Lambda, right? So that's what we'll be integrating. We need to use these two. Anyway, so what I'm going to do is, you can create a EventBridge rule, a rule which matches incoming events and sends them to target or processing, which means like it's like a trigger. Or you can have a pipe that connects event resources, or you can schedule it. I'll be using scheduling, for example. You can also create a schema, registry and organize it. We'll create a schedule. I want to do it a schedule based. Okay, I can have a sample, for example, a name which is sample. Okay, description is optional. Schedule group. Okay, we don't have a schedule group, it's default. Fine. So you need to select what's the schedule pattern. You see here there are 4 steps you have to follow to complete this. We'll do it. So starting with that, you need to give a schedule pattern in step 1. So what is the schedule pattern is, whether it's a one-off thing or whether it's a recurring schedule. Recurring schedule means it happens every time based, for example, every day, every month or like that. Or you can also go with something like one-off schedule, and one-off schedule is something like this particular date. For example, like in November 12, I need to execute this. I can schedule it, so it will be executing that particular thing at that time. That is one-off schedule. Or if I want a recurring schedule which happens every day, I can use that. You have a cron-based schedule. You can set the time, minutes and all exactly. For example, what's the minutes, what's the hour, day of the month or year, you could set that. For example, if I want to type in hours, I can't leave the minutes empty. In such places you have to enter star in that place. Okay, for 4 hours every time you can do it and give star everywhere, and you can select the time window also for it and select the date time. So this is cron based schedule, or you can go with rate based schedule, like every you can select minutes, hours or days. For example, every 6 days I can execute this, or every 1 day I can execute it 1 hour, or for example I'll use 1 minute, every 1 minute just execute it. Okay, so if flexible time window, if you want, you can add it. I'll just go without it. And this is the timestamp Asia or Kolkata. That's good. That's time frame is good, and it should occur every 1 minute. Okay, we'll go with next. Flexible window time. I'll off it now. Next, and you could select from some of the developer tools like Code Build, Code Pipeline, or ECS, EventBridge, put events. I'll go with Lambda invoke. If something happens in the Lambda, okay, just use that and do this. Okay, like every 1 minute execute this code. I don't have one, so I'll create a new Lambda function, which we have here, Mumbai region, and I'll go with, yeah, we can go with event underscore bridge sample. Okay, I'll select Python 3.9 and create this function. And actually EventBridge is using Lambda, so later on we need to give permissions for it also for it to run properly. We'll wait for it to execute so that we can continue to next one. Yeah, it's done. We don't need any trigger. We just a trigger will be given from this event scheduler itself. I just want to add one thing. You can, for example, what is the task you require every day, every minute, or like for example, if you schedule it for every day, what it should do. In such places you can have your code here, and for showing example I'll just go with import date time. It's actually from Python, and I'll just print this particular thing. Okay, a formatted statement, event bridge executed at, I'll use a formatted statement and go with in date time. You can get the date time of now, particularly what is the time now, just print it. I'll deploy this, and this will be used here. I'll just refresh this and click this EventBridge sample, and if you have different versions you can select from it. It don't have version, so I'll skip it and go next. Okay, so after action what it should do, it's delete or none. I'll go with none for now, and I'll just go with the same things which we have here. Okay, so create a new role for the schedule. This is the role, and I'll just copy this. We need it later. Go next, and yeah, that's it. We'll go and create a schedule which every minute it just uses that Lambda function, execute it every minute. You can schedule like this, or if you wanted to do it every day, you can do it every day. And with that, what we'll be doing is now we'll be just we need to check whether it's executing or not. So I should go into the monitor, view CloudWatch logs. I should go and see whether it is executed or not. Okay, right now we don't have any. Maybe it's some issues, or we should wait for it to run. Okay, every minute we'll wait for it to complete, or we'll check any issues or any permissions issues. If we have, it won't be available. The rate is 1 minute. We'll just edit this and check the settings. Permissions, this is the role, right? Go to the IAM console, check does he have the permissions. Okay, EventBridge scheduler. I'll also add for safety purpose, add Lambda, AWS Lambda full access, add permissions. Next, and yeah, save the schedule. So now we'll check for the logs, refresh it, recent invocations, watch CloudWatch logs. Yeah, we could see it has been executed, and we could get that EventBridge executed at this particular timestamp, and we should get it every minute. Yeah, it seems like every minute it is executed. We could see that. So I just use a filter and get this particular thing alone so that we can see how much time it is executed. Okay, so we could see that recently every minute it has been executed at this particular timestamp. And not only that, if time goes on, we should get another few also. So I'll wait for it to print 2 more so that we can wind up this. So every minute it happens. So that's what the EventBridge idea is. If you want to have any repetitive thing you want to schedule, you can schedule it every day. So it will execute that particular task. That's what the idea behind this. It's actually a useful tool which you can use a lot of serverless service and achieve this particular thing. And yeah, so you can use this to see. It seems like a lot more has been done. Yeah, another one has happened, right? So like this, it will be keep on executing, and see here, this executes means you have to pay for it. So if you leave it every minute, it is going to run. So which means in 1 hour, it will do 60 times, and then if you leave it, it is going to build a lot more times. If you want to stop it, you can just delete it or disable it. That's up to your wish. And not only that, this Lambda function also, if you don't have that use, just delete that function. This is for our safety purpose. Now it won't be executing again and again because we have stopped it. Anyway, so that's it about EventBridge. And finally, we have used a lot of services with Lambda and done some projects. So that's it about AWS, Lambda, and other support services which we have seen. So from next session, or in the next session, which is on day 12, we'll be discussing about Amazon QuickSight, which with that we can build a project which is a dynamic dashboard which we will be building. And I'll be explaining about some little concepts about data. Later on, after this, we'll be discussing about a data ETL process. So we need to know about data. So in the next session, I'll be discussing elaborately about data and features inside of it, how to visualize it properly, how to use Amazon QuickSight for a task. And it's also a paid service, so you have to be careful in that. If you get the responsibility of that and understand it and then use it if you want, don't go just blind and then get builds for it. Anyway, so that's it. Thank you. We'll see you on day 12.